Told you need to know this chart for these common amplifiers. Base, emitter, collector, right here. So what's the first thing you have to be able to do? Identify the symbol of the common amplifier. And obviously he's going over base, emitter, collector. Identify schematic symbol. You also have to be able to determine these parameters right here that relate to each type of common amplifier. So the first one being common base. How do we know it's common base? It all has to do with mainly where the inputs and outputs are, right? Right, yes. So for this one, these little circles indicate what? Yes, either test points or an input or an output. Same, it's kind of the same thing. So we always apply our input in this course thus far where? It's always like from the left side, right? The right side, left? The left side. Output's always on the right side. Woo! So therefore, the input's where? The emitter with respect to the what? Base. Output's on the collector with respect to the base. Is that too tough? Better not be. So we can start answering some questions about this now. You have to know this chart. You'll be asked questions about it. Input, emitter, output, or AC output. Because we're talking about the applying the AC signal. Because all of these are what? They're configured in the what region? Active region. Yeah. So what about the phase? Yeah, here's an input. Hey, here's an output, a little bit bigger, amplified. It's in phase. In phase. Then we have to discuss the gains: current gain, voltage gain, power gain. And during the lesson and quiz review and all these things, the current gain for the common base is what? Current gain. Our gain always has to do with the outputs, doesn't it? Yes. So the current gain is, how do we're saying low, I'm here low, but how do we know? Remember the percentages: 100% emitter, 95% collector, and about 5% the base. So current gain, if we're taking our output at the collector, well, 95 is less than 100%, so the current gain must be low. Make sense?
Yes, sir.
Or less than 1. Don't forget, less than 1, low, it's the same stuff. And there's some clues I'm going to give you later. Just a reminder, hey, you can tell if it's this, if the output's like this, or the input's like that. What about the voltage gain for this thing? And mainly that boils down to, hey, I'm using it as an amplifier. My output's here, my base collector's already reverse biased. So there's some opposition there. Just think of like an open switch. Open switch, I have what? Max what? Max voltage, max resistance, basically minimal current. And don't forget, these are just relative terms. If you're looking for high and you see very high, and other distractors say low and pizza crust and banana top, well, you're probably going to pick high. I mean, that's straight up banana top. Power gain. Yeah, it's kind of like, in a way, some fuzzy math, if you will, because we know that power is a product of current and voltage, so it's just a relative term. Power gain high. What about the input impedance, or Z-in? The inputs on the emitter, here's one of the tips. Whenever we're dealing with the emitter, input or output, the impedance is always going to be what? Low. Because that junction, emitter-base junction, is already forward biased. So how much opposition exists? Not much at all. Low. Output impedance, what's up with that? So again, our output's at the collector, and if we're saying our voltage gain is high, Think about the open switch again. Oh, there's some opposition there, or a significant amount of opposition, because I'm taking the output across basically an open switch, aren't I? To keep it really simplistic. And this thing also has a nickname, which is what? Voltage amplifier. That's all you gotta know about that thing. That's it. Characteristics.